Hello dear students, this is Devang Shah from LG Institute of Engineering and Technology. So far we have been learning about the basic electrical engineering and some of the topics we covered like basic RLC components, Ohm's law and Kirchhoff laws. Now in our today's session we are going to learn about very interesting topic which is called star and delta conversion. Right. So in star and delta conversion, why this topic is very important in terms of the circuit design, in terms of the simplify the circuit, because this two star and delta based on the shape of the circuit. Delta is like a loop, star is like a three ends are the floating. So in these are the generalized shape where we need to solve this generalized shape which is available in every and any kind of circuitry, right? So if you want to simplify, if you want to solve a bigger network, you must have to use star and delta conversion, you have to use Ohm's law, you have to use Kirchhoff law. So ultimately here we are going to design a circuit. First thing, once you design a circuit, you need to solve the big circuit. Well, at one point of time you have to find the voltage and current drop across the resistance as well as flowing through the resistance respectively. So my aim is here to design a circuit and then solve the complex circuit, and my job is to find voltage drop across the resistance which is available in a network, which is available in a circuit. Same way I have to find the current which is flowing through the resistance in a big network. So to to solve any big network, this is one of the method that we need to convert any corner of the circuit that is available in a star or delta shape form, and that I need to solve it. So my job is to convert star into delta, and same way the delta into star. So this is in another sense this is called a transformation. So where I'm going to convert delta into star as well as star into delta. That's why this is also named as star delta transformation. So how I'm going to solve this complete network? Let's start and discuss it. So my first job is to find the point number one, where I have to look for the resistance which is available between terminal A and B for the delta. Same way to find the points A and B or the resistance between A and B from the star. So ultimately here or the resistance offered at the terminal A and B of delta network is same as the resistance offered between terminal A and B of star network, right? So both this terminology is same. So from this I can be able to find equivalent resistance between star and delta, this topology or this shape. Same way I have to look for a point number 2 where I have to find the resistance offered by the delta network between terminal B and C. Same way the resistance offered by the star terminal or star shape between two terminal B and C. Same way, point number 3, that the resistance offered by the delta network between terminal C and A, and same way the resistance offered by the terminal C and A of the star network. So if I'm going to see this, and let's try to solve this particular conversion where my job is to, so let's start with uh, first conversion where I'm looking for the resistance offered by the delta at terminal A and B, or the between terminal A and B. Same way the resistance offered between the terminals A and B of the star network. So ultimately both are same. So if I am looking for the resistance between these 2 points A and B, so let's consider the resistance of uh, star terminal between terminal A and B is RAB, and that is equal to, in another way, the resistance offered by the terminal or resistance offered by between the terminal A and B of the delta network, which is R1 in parallel with two series resistance R2 and R3. So ultimately R1 is parallel with series combination of R2 and R3. So R1 parallel R2 plus R3. Now to solve this network, I can consider RAB is equal to RA plus RB from the star side. So once I am going to solve this, this particular equation would be RA plus RB is equal to R1 into R2 plus R3 divided by R1 plus R2 plus R3, because of this parallel and series combination. Now same formula if I'm going to use for rest of the points, like between terminal B and C and between terminal C and A. So uh, once you apply this terminology between two terminals B and C for delta as well as star. So let's go for the point number two, where the resistance between points B and C. So that would be RB plus RC is equal to parallel combination of R2 and R3 plus R1. Right. So from the delta network, if you find R2 into R3 plus R1 divided by R1 plus R2 plus R3. Now the same method we can apply between the terminal C and A of star and delta. So once if I'm going to use here similar resistance from terminal B to C, sorry, from C to A, the resistance between point C to A, that is RC plus RA from the star side, and that is equal to R3 into R1 plus R2 divided by R1 plus R2 plus R3. Right, now you have total three equations in terms of RA plus RB, RB plus RC, and RC plus RA. Right, so from these three equations 1, 2 and 3, we are going to add all these equations. So if we are going to add all this equation in that form, if you find the terminology, you find the next equation. So ultimately all this solution is based on the mathematical solution. So ultimately here we have to play with all these equations of RA plus RB, RB plus RC and RC plus RA. If you adding all these three equation 1, 2 and 3, you will find the solution in terms of mathematical terms is 2 in bracket RA plus RB plus RC is equal to 2 in bracket R1 into R2 plus R2 into R3 plus R3 into R1 divided by R1 plus R2 plus R3. Right. So if you are going to cancel the 2, so you will find the equation number 4, which is RA plus RB plus RC, that is equal to R1 into R2 plus R2 into R3 plus R3 into R1 divided by R1 plus R2 plus R3. That is my equation number 4. Now this is my most important equation. From this equation I can be able to find rest of the equation in terms of RA, RB, RC, or in terms of R1, R2, R3, right? So if I am going to use this particular equation, and so and apply, like I have total three equation found in terms of RA plus RB, RB plus RC and RC plus RA. Now fourth equation is a combined equation of RA plus RB plus RC. So if I am going to subtract equation number 1, 2, 3 respectively from the equation number 4, I would be able to find the separate equations of RA, RB and RC, right? So once you are going to subtract the equation number 1 from equation number 4, equation number 2 from equation number 4 and equation number 3 from equation number 4, then you will be able to find RA, RB and RC. These equation are in terms of the delta equation. So ultimately that shows the delta to star conversion, where once you are going to use this particular formula, you will find RA is equal to R3 into R1 divided by R1 plus R2 plus R3. This is my equation number 5. Same way, if you subtract the equation from the equation number 4, you will find the RB, that is equal to R1 into R2 divided by R1 plus R2 plus R3, and RC, that is equal to R2 into R3 divided by R1 plus R2 plus R3. Now you can see here all these equations are individual equations of RA, RB and RC, where that conversion is referred as the delta to star conversion, right? Where RHS part is completely uh, uh, star part, and LHS part is completely a delta terms, right? So by that way you can convert delta into star. So this transformation, this conversion is delta to star conversion, right? Now again, to continue with all these three equations, equation number 5, 6 and 7, that's the separate equation of RA, RB and RC to further convert from star to delta. So what here we are going to do, we are going to use all these 5 equations here, and we'll try to solve the reverse conversion. Now before that, we need to learn, let's say in particular circuitry, all those resistances of star network R1, R2 and R3 all are same value as R. Then in that case we consider this terminology as R1 is equal to R2 is equal to R3 is equal to R. Then that what would be the equation of RA, RB and RC? So ultimately here RA, RB, RC I consider as small r, and that is equal to R by 3. So this is like our one of the case, if all the resistance of star networks are same, then you can do the divide by 3 and you will find the conversion of the delta resistances, right? Now next here we are going to solve this particular terminology, where now we have to convert here star into we have to convert delta into star. So we have total 5 equations. uh, um, so far we have total 3 equations, equation number 5, 6 and 7. So we use this particular formula to convert this star to delta transformation, where we have to multiply here equation number 5 and 6, equation number 6 and 7, and equation number 7 and 5, and adding all together. So once you are going to do this, you will find the next equation in terms of RA into RB plus RB into RC plus RC into RA, and that is equal to R1 into R2 square into R3 plus R1 into R2 into R3 square plus R1 square into R2 into R3 divided by R1 plus R2 plus R3 of whole square. Once you are going to solve this equation, you will particularly you will find here RA into RB plus RB into RC plus RC into RA, and that is equal to R1 into R2 into R3 divided by R1 plus R2 plus R3. Right, now that particular equation number 8 you can see here, that's a generalized equation. In that term, the uh, right hand side you will find R1 into R2 into R3, that divided by R1 plus R2 R2 plus R3. Now you can see this from this particular equation 8, you can extract the individual equation of RA, RB and RC. Once you are find, or you are looking for equation number 5, 6 and 7 from the equation number 8, you would be able to find the individual equations of star network, right? So you can see here from this, uh, if you extract the particular equation 5, 6, 7 from the equation number 8, you will be able to find the equation of R3, which is the individual equation R3, that is equal to that the delta equation, one of the resistance of delta equation R3, that is equal to RA into RB plus RB into RC plus RC into RA divided by RB, right? Same way, if you look for the resistance R1, that is equal to RA into RB plus RB into RC plus RC into RA divided by RC. Same way, R2, that is equal to RA into RB plus RB into RC plus RC into RA divided by RA, right? So that's how you can be able to convert, it's a star to delta conversion, right? So all the star resistors you have converted into a delta. Now this is a common terminology, where uh, here ultimately all those equations we are finding, the dividing the equation number 8 by equation of 5, 6 and 7. Now same way, this is case number 2. If you are going to take all the resistances RA, RB and RC, all are the same resistances as R, then you can be able to find the generalized equation of R1, R2 and R3, that is equal to 3R, right? So straight away you can directly use this case number 2 equation, as you can see here. Right, now some of the complete theory in terms of star and delta conversion. So you have a combined uh, circuit of star and delta. You can see here a triangle that shows the delta, and inside the shape of Y, that is shows as the star network. So this in some of the book it is also written as Y and delta network, right? Or they have used the shine like triangle and Y. So this is the combined circuit of star and delta network, where you will find a total 6 equation, and those 6 equations are those 6 equation shows the transformation of star to delta and delta to star. So one equation is already here, that we just found that R3 is equal to RA into RB plus RB into RC plus RC into RA divided by RB. So you can also write this equation in this way, like you are going to nullify, you are going to remove the RB from the numerator part and denominator part. So you can also write the equation of R3, that is equal to RA plus RB plus RC into RA divided by RB. That's one of the equation from the this particular equation, right? Same way you can be able to find a R1, that is equal to RA into RB plus RB into RC plus RC into RA divided by RC, and equation of R2, that is equal to RA into RB plus RB into RC plus RC into RA divided by RA, right? So this equations where we have solved or we have converted star to delta. Right, now the another conversion from delta to star, you can see this particular equation where this conversion where I need to find one of the resistance of RA, which is a star register, and from the all the delta registers. So you can see here RA, that is equal to R3 into R1 divided by R1 plus R2 plus R3, and RB is equal to R1 into R2 divided by R1 plus R2 plus R3, and RC is equal to R2 into R3 divided by R1 plus R2 plus R3. Now how you are going to remember all those equations? You just focus on the particular combined circuit where you can see here the RA, which is in between the resistance of R1 and R3. So RA is equal to in between of resistance R3 and R1. So you can write in a numerator part like R3 into R1 divided by the total resistance of the uh, delta shape. So R3 into R1 divided by R1 plus R2 plus R3. You can see the equation number 5. Same way RB, you can check here RB is in between R1 and R2. So same formula you can apply, same method you can apply. Same way the RC, it is in between R2 and R3, same equation you can apply, right? But what about from star to delta, right? Where you can, if you are looking for a resistance R3 particularly, so if you are you can see from R3 side, you can see only two resistance RC and RA and RC, but RB resistance is the opposite diagonal or opposite part, so that you cannot see. So ultimately that part you cannot see, that means you can straight away put in a denominator. So that's how you are you can remember all this equation of the conversion of star to delta as well as delta to star. So I hope you can remember the complete theory, and it's just a mathematical form. Thank you very much, dear students.